Hello guys, welcome to my channel. So today's video is day 12. So in day 12 we had to cover as mainly advanced grouping functions. So the advanced grouping functions are mainly we had to cover in this one mainly how to use group by, cube and roll up for multi-level aggregations. So this cube and roll up. And another one is performing self join to query hierarchical data within the same table. And finding the pairs of records with specific criteria using self joins, utilizing cross joins to generate all possible combinations of two datasets, understanding natural joins and how to take them in the SQL Server. So these are all the concepts mainly to focus on day 12. So day 12 is mainly group by, cube and roll up, self join, cross join, natural join. So these are all the first for this. What are all the tables are required? So first we'll create the tables. So first I will remove the existing all the tables. After then we required the tables are bookings table, employee table, and films table, payment table, customer table, and insert the records. So for this booking table, we had to insert the records, and employee table, we had to insert the records. Films table, we had to insert the records. Customer table, we had to insert the records. And finally, payment table to insert the records. So this is done. Now we had to come into the first concept called as the group by and roll up. So in this scenario, the scenario is mainly to calculate a booking amount roll up for the hierarchy of quarter, month, week, in month, and day. Okay. So let's see the scenario. The scenario is mainly booking amount roll up by quarter, month, week, and day using group by roll up. Okay. So in this situation, what is happening called as the main purpose of this query is mainly to calculate the total booking amount at various levels. That is day, week, month, quarter, and grand total. So what are all the functions we have to use in this part mainly? So the functions called as mainly, we have to use one function called as the date part. So the date part is mainly will extract the quarter, month, week. So if it's required, we'll get the day also. So, and another function we have to use called as the main one, that is the group by roll up. So this group by roll up is mainly creates subtotals and grand totals based on the hierarchy provided. So it aggregates data from the most granular level, that is up to from day to up to the grand total granular level. Okay. So the result is mainly we'll get the detailed breakdown of booking amounts for each day along with subtotals for each week, month, quarter, and an overall total. So like that. So let's look into the query part. How we'll write this query. So for this query, we need the table name called as the bookings. First, we'll write the select from bookings. I'll write the table name. Now I will write as here, as I mentioned in the functions I have used. So the first function we have used as date part. So from this date part, we will extract with the quarter, month, week. So here I will write here date part of we need quarter, comma, booking date. as quarter, comma, same thing we'll write as, here we'll write month, same thing, copy as write month. Next one, for month place we'll write as week. So this one as week. So now here we'll get the, for this we'll get, I'll show here how it is one will work. Okay, so this is the quarter number, month number, and week. Okay, so this way we'll try to get the this all group by cube and roll up. So only for this, we will get the quarter and month in this one. Now I will get with day wise. That is booking day, booking date as day, comma. Now I want total booking amount. That is sum of booking amount. Sum of booking amount as total booking amount. Okay. So up to this one, fine. After then, we have to group by roll up. So now I will write the group by roll up. So roll up of what are all the functions we have to roll up? So roll up is first thing quarter, month, week, and booking date. So all four functions we have to use. So that is I will copy this one. Group by quarter and month, comma, week, comma, and date. That is the day. Okay. Now we'll close this one. Up to this one, we have to written as the group by roll up. Okay. Now I will execute for this one. Something error. Group by roll up. Okay, fine. This one will give space. Quarter, month. Again, we'll try. Year, hyphen. Where is the hyphen? Something error. First, we'll execute this part. Booking amount. Yeah, okay. Booking amount. Got it. Total booking amount. Done. So if I execute this part, so I will get the result like this way. Okay. But this is not in the proper order. So we'll try to get the order by quarter, comma, month, comma, week, comma, day. So if I execute this part, I'll get the proper order now. You see this one. So quarter, month, week, and day, total booking amount. Okay. So this way we will get with the group by and roll up. Same thing we'll get with the cube. So what is this cube called as mainly? So group booking amount roll up using group by cube. So this cube is mainly the query calculates the total booking amount for all the possible combinations of the specified date parts. So specified date parts called as what it is doing with the group by cube is mainly. So it generates a result set that shows the aggregations for every possible combination of the grouping columns, including subtotals and grand totals. So let's look into this part too. I hope the query is to be same as usual, and only we had to change with this with the roll up we had to use with cube. So here I am using cube. Everything is to be same only. Now we'll try to execute this part. Okay. So earlier some null values and so on. So the detailed way. So now I am getting this way, the result. Detailed way. Okay. So first quarter. In the first quarter, first month, second month, and third month. Week. In the first week. In the first month, week. First week, second week, third week. Okay. And day. Detailed way we had to get. Okay. So this is called as the group by cube. Next, we'll look into self join. So in this self join, no, this is very most important question in the common interviews. Every interview, this question will arise. Self join. So the self join is scenario is find all employees and their managers. Find all employees and their managers. So here list of employees with their managers using self join. So here we'll use with the self join. Example I am using with select from employee. Okay. Select a star from employee. If I execute, I'll get the employee ID, name, and manager ID. So here we want to find the managers. Okay. Find all employees and their managers. So who are all the manager name we had to get to. Okay. So that we had to write as so here. So this is simple. Just we'll use with self join. Okay. So self join called as so we'll employee table only we had to join as some alias name. One is employee, one is manager like. Okay. So for example, now I want to use with so this employee called as so EMP, let's assume, and left join. Same thing will connect to employee and MNG. So MNG called as the manager on EMP dot manager ID equal to MNG dot employee ID. So here, if you know, here employee ID, manager ID. Okay. So if this is equals, okay, the condition is to be matched, then we'll write the select part. So select part I will write as so EMP dot employee ID. So this is I'll get the employee ID. From the employee table, we'll get the name as employee, comma, and manager name. So MNG dot name as manager. Okay. So for this, we are getting the 3 columns. So employee ID, employee name, and manager name. Let's find this one. Okay. So I'm getting the manager name. So manager name is for employee ID 1. Employee name is John. So no manager. Employee ID 2. Employee name is Jane and his manager is John. Okay. Like this. So this is the one example of self join. So mainly this purpose is to list the each employee along with their manager's name. So self join is mainly EMP is the alias for the employee, MNG is the alias for manager. Okay, right. Next one, find the pairs of films with same length. So same length calls here we'll use with a self join only, and the table name we are using here films. Select from films. Okay. So if you look into the films, what are all the columns are available? So I have film ID, title, and length. So what we need to require mainly to find all unique pairs of films that share the same length. So here I will remove the star from the films. I will call as F1. So let's join films F2 on F1 dot length equal to F2 dot length. Okay. And so this is one condition, length, and F1 dot film ID equal to F2 dot film ID. So here we are writing two conditions. Okay. Now we'll write the select part. So in select part, I want to display as the first film title and second film title, like film 1 and film 2. So for the F1 dot title as film 1, comma, F2 dot title as film 2, comma, F1 dot length. Okay. Now I will get the film 1, film 2 and length. So the difference also. So find the pairs of films with the same length. So let's try to this one. Okay. So film A, film 1 and film 2. Film A 120. So film B 90. Film C 120. Film D 90. Film E 100. Like this, the same length films we had to get. Now we'll look into the other one, cross join. So this cross join is mainly the main purpose of this cross join we'll use as in this scenario to generate all possible combinations between customers and payments. Okay. So our scenario also same thing. That is to find all the possible pairs of customers and payments. Okay. So for cross join is mainly it's like a Cartesian product of two tables. That is, so here in this scenario, the meaning is every row in customer is paid with every row in payment. So here we are using with two tables, right? One is the customer and second one is the payment. So let's look into this one. Select from customer C, cross join payment P. So this is the cross join. Now I will include with the select part. Now I want customer name, payment ID, and amount. Okay, I want these three columns. So if I execute this part, okay, this is the way. So customer name, payment ID, and amount. Okay, find all the possible pairs we'll get. Right. The next one is the natural join. So this natural join is mainly first note point is SQL Server does not support natural join. So we simulate it with a join on common columns. Okay. So generally the natural join is not supporting by SQL Server. So our scenario is mainly to find all payments with customer details using natural join. Okay. So in this one, the natural join we simulate with a join on common columns. So the purpose is mainly in this scenario called as the purpose is mainly to combine payment records with corresponding customer information based on shared columns. Okay. So shared columns, so we'll look into this one. So here we'll use with payment table and customer table. So we require find all payments along with customer details. So let's write this one. Select from payment P join customer C on P dot customer ID equal to C dot customer ID. Okay, so this is the join condition. Now we require payment ID, comma amount, comma customer name. Okay, so this way we will get with find all payments along with customer details. Okay, so payment ID with customer details. But here in this direct natural join is not working. So we are simulating with common columns. Okay, so this is the simulation of natural join. So in this case, mainly a natural join automatically join tables on all columns with the same names. So SQL Server does not have a natural join keyword. So we specify the join condition explicitly. Okay. So the result is mainly the comprehensive list of payments that includes payment IDs, amount, and the names of customers who made them. So final in this we have covered as self join, cross join, grouping sets. So that is natural join. So first one has the self join. So in self join, it is useful when dealing with hierarchical data or when you need to compare rows within the same table. That is the self join. And cross join called as mainly it should be used cautiously as they can produce very large result sets. So especially with the large tables and grouping sets. So grouping sets are mainly cube and rollup. So which is a powerful for the generating reports that require subtotals and grand totals across multiple dimensions. So natural join is mainly, so it is while it is convenient, they can be ambiguous if tables have multiple columns with the same name, but different meanings. Explicit joins are often preferred for clarity. Okay, so this is the video for uh, day 12, self join, cross join, cube, and roll up natural joins. Okay, thank you. Thank you for watching. If you like the content, please like and subscribe. Thank you.